Hello everyone. In this problem, the hexagonal lamina of 25 mm sides on one of its corners on HP. The lamina makes 45 degree to HP and diagonal passing through the corner on which it rests is inclined at 30 degree. The diagonal passing through corner. Then it is beta method problem. Construct the hexagon of corner case. Before that, write the xy line thin line and name those xy and write it xy and pphp. All four are capital letters. See, this is corner case, then it has to be circle method. You construct the hexagon circle, that is drawing the circle using compass diameter, side dimension is 25, diameter you take 50, diameter. Then next, draw horizontal line, okay, for corner case problem. Then next, take a compass take a compass take a compass take a compass from this corner to 25 mm radius. Cut it 25, cut it one more side and another side 25, cut it and again one more 25 mm, cut it. Now join those all six corners by thick line by using scale. Start with first corner, second, third, fourth one, fifth one, sixth one and close it and show the dimension for any one edge with what of the six edges. Show it one dimension, those 25 mm. And next, name those six corners A, B, C, D, E, F. Okay, naming with small letters. We have to name those top view. A, it's our B, C, D, E, and F. Project upwards for front view. All those lines are thin. It has to be thin lines. You have to use two project lines. Okay, start with A end point up to XY line. Then B and F are same line. Project it. Then F, C and E are same line. Project it. Then point D you project up to XY line. Now front view is straight line. One line from D dash to E dash. One line from E dash to F dash and one line from F dash to A dash and name those points front view points. This point is above the XY line A dash. Okay, name it A dash. B dash visible, F dash within bracket and C dash visible, E dash within bracket and last point is D dash reference point. And this with respect to D dash is the reference and it is inclined to HP at 45 degree and measure this distance from D dash to A dash, whatever the total length, using scale you measure it. The length is exactly, it is 50, okay, 50 mm. And taking the protractor, the 50 mm length with 45 degree, you construct from XY line 50 mm length, 5 centimeter, 45 degree angle, 45-degree angle. Okay, first show the angle, then mark those later A dash, B dash, that is C dash and B dash points. Mark those inclination 45 degree. Then measure the distance of D dash to C dash. Measure the distance of D dash to C dash. Okay, here C D dash to C dash is 12.5. Okay, 12.5. Taking compass 12.5. Total length is 50. 12.5. You cut it. And again the B dash E dash is from A, it is 12.5. 12.5 from D means it's 37.5. Now name those points for the naming is reference base is D dash, naming base is D dash, this point is D dash, and next these 2 points are C dash and E dash, these 2 points are B dash and F dash, last one is A dash. Okay, now project for top view, downwards thin line, downwards thin line, A dash, A dash and D dash on same line, downwards, then next B dash and F dash, project it, and next C dash and E dash, last point is D dash. Now project here B and C are, B is here, C is here, and next A and D, A is here, D is here, and next F is here, then E is here. Okay, now using eraser, okay, A up to here, then B is here, then C is here, then D is here. Now name those points A, B, C, D, E. Top views, this the point is A. Start naming. Later you join those apparent lamina. A, it's our B, it's our C, D, E, and this point is F. Now using scale, join by thick lines all these 6 corners. A, B, C, D, E, F, 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 you are not getting F, this point is F, E2, F, then again A, and okay, this is the apparent lamina of hexagonal lamina. Okay, and it's a beta method problem. Now measure the original lamina horizontal distance and apparent lamina horizontal distance. Okay, according to problem, the third VP angle is given 30 degree. Draw 30 degree line. Draw 30 degree. Draw 30 degree. 30 degree line. You can draw towards right side or towards left side. Any side you can construct this 30 degree. Okay, construct. The line is 30 degree. Okay, now measure the distances first. Original lamina A to D. Okay, A to D is exactly 50. Already know. Here to here is the length is, if could have measure, this length will come from this point to A to this point is the dimension will come 50. How to show? Right, by using scale the distances you have to show. This distance is virginal lamina horizontal distance, taking the length from here. Okay, compulsory you have to show 50, and next you have to take this apparent lamina here to here. This length is around 35 mm. You will get this dimension is 35 mm. You have to show with 35. Now on this line mark AD, original lamina distance first. Original lamina, to find out the beta angle AD, first you have to mark. I'll use those medium thick line to construct on 30-degree line A 50 mm, 50 mm on this line. Okay, before that, without forgetting, show this angle, write the angle of 30-degree from XY line to this line is angle is 30. Okay, now draw the locus line from this whatever 50 mm we have taken. See, this end point is draw locus. Okay, mark the point is, the first point is here, the A point is A, and this one is D. I will mark first to avoid the confusion. This is our A, it's our D, original lamina D, and this distance already we knowing that is the length. Okay, if you have confusion, just make it dark line for this AD first. Okay, AD, and next this AD, use compass, cut this locus by 33 mm. 33, A is the center, 33 radius, you cut it and join by line this D to A, and using scale can project up to XY line. Using protractor, measure the angle from XY line to this. You will get so much of degree. Okay, that is show it. And now this point is our A. This is our apparent lamina D point. Name those D first. Name it D. Now another point E, C, F, B. By arc method we have to project. Okay, take the D is the center. Okay, E radius is 23. Then D to C also 23. Okay, you take D point 23 mm, draw one arc. Again D is the center, 23, one arc. Same radius from A to F also. Compass 23, one arc. Again A is the center, end point exactly 23, one arc. Cut these arcs by using diagonal distance from D to F. D to F is 23 then again D to B also 23, then A to E also 23. Okay, the diagonal lines 23 is here. This is 23, you cut it. Okay, 23, this point also you can cut, from this point also 23 you can cut. Okay, we have drawn this taking first D to E, D to C, A to F, A to B, and next to get intersection, same opposite method, the diagonal. A is the center, A is the center. To get A to E, it is the radius, it will come 34, 34, 34. You cut this and same radius 34, you cut it this side, and again D is the center, 34, you cut it, and D is the center, 34, you cut it. And now name those points, name those points, name those points. A and D is there. Next point here is B. This is B. Okay, it's C. D. This is E. It's F. Joined by thick lines. Joined by thick lines. With start with A. End point A to B. B to C. B to C. Just end point, end points. Use it. Here B to B to C, C to D, D to E, E to F, F to A, F to A. Okay, this is the hexagon you will get. And next zoom, and this hexagon must be always, it has to be thick. Thick line. Now taking line, project for front view, project for front view. Those projection lines, you start with A and B and F, and next C and E dash. Now start with A point first. A top, then B. B is here. Then next C point is here. Almost it will come nearer. Next D point is an XY line. Next E point is here. Then F will come here. Project, and now those extra lines. Name the points. All those corners. Later you join it. Start with A dash, and this is our B dash. It's C dash and D dash, E dash and F dash, and joined by thick lines with line using scale. Start with A to B, B to C, C to D, C to D, D, C to D, D to E, then again E to F, then A. A is completes your hexagonal lamina beta method problem.